Welcome back, everybody. So far, we've only talked about events and a theoretical probability of which remains unaffected by other events. We call these independent, and the simplest example is flipping a coin. You always have a 50% chance of getting tails, regardless of the result obtained with the previous throw. In addition, we can have dependent events. Their probabilities vary as conditions change. For instance, take the probability of drawing the Queen of Spades. Normally, the answer is 1 over 52, since we have exactly one favorable outcome and 52 elements in the sample space. Now, imagine we know that the card we drew was a spade. Our chances of getting the Queen of Spades suddenly go up, since the new sample space contains the 13 cards from the suit only. Therefore, the probability becomes 1 over 13. Okay, now imagine a different scenario. Instead of a spade, we know our card is a queen. So the sample space only consists of 4 cards. Therefore, the probability of drawing the Queen of Spades becomes 1 over 4. With this example, you could clearly see how the probability of an event changes depending on the information we have. This is a very important insight relating to this whole section. Okay, before we move on, let's introduce some new notation. As usual, suppose we have two events, A and B. To express the probability of getting A, if we are given that B has occurred, we use the following notation: P parentheses A, vertical line B parentheses. We read this as P of A given B. Going back to our card example, event A is drawing the Queen of Spades, and event B is drawing a spade. Therefore, P of A given B would represent the probability of drawing the Queen of Spades if we know the card is a spade. We already calculated this earlier, so P of A given B equals 1 over 13. Similarly, if event C represents getting a queen, then P of A given C expresses the likelihood of getting the Queen of Spades, assuming we drew a queen. Thus, P of A given C equals 1 over 4. Perfect. We call this probability the conditional probability, and we use it to distinguish dependent from independent events. In the next lecture, we are going to show you how to compute it and interpret conditional probabilities. Thanks for watching.